All right. Hopefully you guys can hear me, yeah? Great. Well, looks like you can at least. Okay, so you got your, thank you. Yeah. I'll appoint you police back there, I mean, how about that? You got your test back? Okay, test 1 is always bad. So if you're feeling like, man, that was not that much fun, it probably wasn't, and I'm sorry. But hopefully you can go back and look at the practice test and the actual test and just see that they're essentially the same. So I'm not out to get you guys. As long as you're comfortable with the practice test, then you should be comfortable in the test as well, right? And so, like I said, test 1 is hard. A lot of that has to do with just, there's a lot of material kind of coming from everywhere, right? We're doing linear programming, we're doing monopolies, we're doing some derivatives in there, right? And then we've got some merchandising in there, and there's a lot of stuff, right? What's nice about test 2 is it gets a little bit more focused, right? So starting today, we're going to start talking about simple interest, and then we build that into compound interest, and then we build that into annuities, and it just has like a nice flow from here on out, okay? So it will be better, right? More coherent at least, okay? One thing that I will say is, as long as you're improving, so if you do better on test 2 or do better on test 3 or do better on the final, as long as you're improving, I can bump those weights up a little bit, right? So we can shift the weight from test 1 because it is hard. As long as you're doing better in future tests, then it's not gonna pull you down so much, okay? So always just keep going. Don't be dragged down if this was a bad test, which it always is. And if you feel like you did well, then that's really, really good. Okay? But most people, I think, we're just getting to know each other, right? So you don't know how I test or anything like that. So that's part of the problem. But yeah, so if you haven't gotten your test, then you can come grab it after class. And I'll bring them on Thursday too. And until they're all picked up, because I don't want them. And the solutions are posted on Moodle. All right. Okay, so just a little bit of review. Oh, any questions about the test or anything like that before we get started? No? Cool beans. All right, so for review, we really just talked about the laws of exponents. Oops. Laws of exponents. And there was a long list of the laws of exponents, and we talked about log laws, right? Same idea. What can we do with logs? Essentially, we use logs. We use logs to solve for x when x is in the power. Right, and so if we have 7 equals 4 to the power of x, for example, right, how do we solve for this? We said, okay, well, if we take the log, and we use the natural log, which is ln. Oh, yes. Oh, I forgot to set the mood. How could I forget? Oof. Good, better, best. Yeah, I know, it's so hard to see. Anyways, that's cozy. So the log laws, or logs, help us bring that exponent down, because what the log laws say is that if, as long as we're taking the log of both sides, then we can rewrite the log of 4 to the power of x is the same as x times the log of 4. So it just brings that x down in front, and then we can solve for it, right? And so that's the value of knowing logs and how they work. Because now we can just say, well, x must be the log of 7 over the log of 4. To do the log on your calculator, right, the log of 7 on your calculator, you're going to have 7 on your screen. Oh, or maybe not. No, that is it. Okay. Let me try again. Yeah, 7 on your screen, and then hit the LN button, which is the 4th up from the clear button. So 4th up from the bottom left, or down 1, 2, 3, 4, 5, 6 buttons. And then hit the equals button. So 7 and then log equals, just in case, because it showed up, but sometimes it doesn't. So hit the equals, and I get 1.945910149. Or in this case, x is 7, the log of 7, divided by the log of 4. Once we do that on our calculator, we get 1.403677461. You want to make sure that you're getting the same answers, right? So that's why I write all my long answers, right? Just so that you can check to make sure that you're getting the same values. So that's what we did last day. We're going to parking lot that for a little bit, and start finally talking about simple interest, which I said is going to lead us into compound interest, which is going to lead us into annuities. And then a little tweak on that is annuities due, and then mortgages, and then the course is over. What? That's it? I know, right? So kind of from here on out, we start talking about essentially the same thing. Okay? And so I'll start here. Section 4.2 is on simple interest. So at its core, from here on out, we're going to be dealing with, okay, so you either deposit some money in the bank, it sits there for some amount of time earning interest, and then you take it out and you have more money than you started with, right? Or you get a loan from the bank, you borrow it for some amount of time, you have to pay interest. When you pay it back, you pay back what you borrowed plus interest, so you pay back more than what you had to borrow, right? And so we're just dealing with, okay, well, how do we calculate that amount of interest? Okay, so here with simple interest, just like the name suggests, it's like the most base case that we could be dealing with. And then we kind of blossom out from there. So in general, we have an initial deposit, which is either an investment or a loan, depending on which side you're on, right? A deposit to you or from you, right? Doesn't matter, they behave the same way, is called the principal, which we denote by a capital P, or we can also call it the present value, which we'll call PV later, present value. That's not until, we don't adopt that notation until compound interest, right? But it's good to keep in mind that they're the same. P and PV are going to be the same, which I think everyone's on board with. Yeah. So an initial deposit is called the principal, or we can also call it the present value, and it earns interest, at some specified rate which we'll call lowercase r, or denote by lowercase r, for a specified amount of time, which we'll call lowercase t, to yield a future value, which we'll denote by FV, capital F, capital V. I'll use the shorthand. The future value, right, is the principal plus the amount of interest. The future value is the principal, which we denoted by P, plus the amount of interest, which we'll denote by capital I. Just like before on our formula sheet, right, we had the rate of the markdown, so the ROMDA, and capital D, which is the amount of the discount, or the ROMU and M. The ROMU is the rate of the markup and M is the markup, right? So it's the amount of the markup. Same idea here. I is the amount of interest that you have to pay, whereas R is the rate of interest, right? So you have to keep those separate. Okay? If you've got your formula sheet handy, I've got a couple extras if you are missing yours. But if you've got your formula sheet handy, right, we're working through the simple interest formulas. And the first one on there says that capital I is capital P times R times T. Okay. That's on our formula sheet. This says that the amount of interest that you have to pay or get paid is the principal amount times the rate times the time that it was sitting there for. And I'll add that the future value we said was P plus I. Okay. That one's not on our formula sheet, and we're going to come back to this in a little bit, right? But it's just good to have it all summarized in the same place, right? Because that's not the formula that you have on your formula sheet, right? But we're going to derive it, not that crazy, right? Replace I with PRT, pull out the common P, and then you have the formula on your formula sheet. That was a spoiler alert, because we're going to do that later today. But anyways, so it's not that crazy, right? But for now, we're just going to deal with I and just getting comfortable with the amount of interest calculation. And so I'm just going to summarize that where I, capital I, is the amount, and I'm going to emphasize the amount of interest. Right, this is a dollar amount. or whatever currency you want to work in, but we'll work in dollars usually. Capital P is the principal amount. And so that's also an amount, and it's a dollar amount. Lowercase r is the rate of simple interest per year. Rate of simple interest per year. Okay. That's going to be important because I might say, okay, you have to pay 2% per month, right? You have to convert that to years or to 24% per year. Yikes. Right, and so it's always, so your R has to be per year. Okay? And just the note, right, for these interests, right, we always give it as a percentage, but in our calculations, we have to use the decimal value, right? So use decimal in calculations. And T is the time in years. Years is important, right? Because again, maybe you only deposited it for 3 months, right? You don't want to use T equals 3 because 3 months is not 3 years, right? And so you have to keep track of, okay, well, T has to be in years. So if it's 3 months, then you have to take 3 over 12, and that's in years, right? So you just want to keep track of the units, I guess we could call them. The time is in years. The rate is in the interest rate per year. Right? They have to match up. Okay. Any questions so far? How about an example? Example 132. If $5,000 interest, hey, wouldn't that be nice? Or maybe not if you have to pay it. Interest is earned, is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? What amount was initially invested? So we'll just highlight some things that we know, right? We know that the 5,000 is the amount of interest earned, right? And so it has to be I in 1 year. That must be our T. At an interest rate of 7.3%, that must be our R, right? We are assuming that it's 7.3% per year, and it's safe to do so, especially for these simple interest problems. If it doesn't specify 7.3% per month or something like that, we can just assume that it's per year, right? If it doesn't say. Assumed per year. Right. We are assuming that, but it's pretty safe. And then what amount was initially invested? We want to find P. So we've got our formula, I equals PRT. we know that I must be 5,000. P is what we're trying to solve for. R, we have to use it as a decimal, right? So 7.3 divided by 100 is 0.073 times T, which is 1 year. .3% divided by 100, 0.073. Just highlight that, because that's going to be really important. Otherwise, we get a really weird answer. Okay. Solving for P, right? We can 0.073 times 1 is just 0.073, and then we can divide both sides by 0.073, so we get P is 5,000 divided by 0.073. So P, let's see here, 5,000 divided by 0.073, 68,493.15068. And again, I'm just writing out my full answer just so you can check your calculator work. But P, remember, is a dollar amount. It's the principal amount that we invested. And so in dollars, we always round properly to 2 decimal places, but not until the very end, right? You're not rounding throughout. You're just keeping all your decimal places until the very end. 68,493.15. I prefer to just always start with the base formula, right? But some people, and I'll show you, prefer to just solve for P first and then plug in the values. And so I'll show you what I mean, right? We could have solved for P first, then plugged in the values. So we have I equals PRT. Solving for P, we get P is I divided by R times T. Right. That gets you to the same place, right? So it's just a matter of knowing what you like. I happen to like to always start with the same formula and then figure out what I need afterwards, I guess, but it doesn't matter. Okay. The solution will be the same. All right. Any questions about that one? No. Let's do another example. So example 137, I've got it written out here for some reason. So here we go. Jim's calculations show that the total interest owed to Jill on his $2,700 loan is $315.90. So let's start that. Jim's calculations show that the total interest owed to Jill on his $2,700 loan is $315.90. If he paid simple interest, at a rate of 0.9% per month for how long did Jim borrow the money? For how long did Jim borrow the money? So again, I'm going to go through and highlight things, but this time because there's a little bit more, I don't know, more text, I guess, I'll summarize what we've been given below, but first I'll just go through and highlight it, right? So the total interest owed to Jill on the $2,700 loan is $315.90, right? So this $315.90 is the amount of interest, right, that he has to pay. The initial loan was $2,700, so P is $2,700. Here's where we have to be careful, right? Because he's paying simple interest at a rate of 0.9% per month, right? So we have to have an alarm bell that says, oh, that's per month, so I have to change that to per year before I can do anything. Right. And then for how long, so we want to find T. Right. But like I said, I'm going to summarize this a little bit better here. So we've been given that P is 2,700. That's fine. I is 315.90. And R is 0.9% per month. So first thing we have to do is we have to convert the 0.9% per month to a rate per year, right? So first, we need to convert 0.9% per month to a rate per year. Okay, 0.9% divided by 100% is 0.009. Per month. 0.009 times 12 months per year technically, if we're saying 0.009 per month, we're saying 0.009 over a month. And then to cancel, right, you have to say, okay, well, I need a month here and a month here so that I can cancel 12 months over 1 year, right? That's the same. So now I get 0.009 times 12 is 0.108 per year. Oh, per pair. Per year. So there will often be that extra step where you might have to change the rate to make sure that it's per year, or change the time to make sure that it's per year. Otherwise, there's nothing about it. Okay. But now we know R per year. So now we can use it. So I'll just say R equals. So we have I equals PRT. I was 315.90, P was 2700, R we decided was 0.108, it's already a decimal, times T. Solving for T, I get, sorry, 315.90 divided by 2700 times 0.108. And I'm just showing all my steps, just mostly so that when you go back and look at it, it's all there. You don't have to show all these steps. 291.60. 315.90 divided by 291.6. Excuse me. I get 1.0833 repeating years. T is always in years. Or same idea, right? If you wanted to solve for T first and then plug in the values, it really doesn't make any difference, right? Or we could have solved for T first and said, well, I equals PRT, so T must be I over P times R. Either way, we get the same results. Any questions about that one? Nope. All right. Example 138. We're gradually building these up into slightly harder problems, but nothing you can't handle. Just paid interest charges. Just paid interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. That was 2 months overdue. What monthly rate of simple interest was she charged? Funny question, I know. Okay. Let's just go through and highlight what we know, right? So paid an interest amount, right? So this must be the 169.05 is right? The amount of interest. The initial invoice was for $4,830, so that must be our P. And then 2 months overdue, so this is T, sort of, right? 2 months, 2/12 of a year. Right. And then here's the sneaky part. What monthly rate, right? So R is our annual rate, the yearly rate, right? But now we want what monthly rate. So find R per month. So let's just summarize here. We're given that I is 169.05, that's fine. P is 4830. T is 2 out of 12, right? 2 months. Two months converted to years. Right. There's 12 months in a year. And we want to find R, sort of, per month. Okay. So what we're going to do is we're going to find R per year and then convert it to per month. Right. Slice it up. So we've got I is PRT. The amount of interest was 169.05, which is P times, which is 4830 times R, which is what we're solving for, times T, which is 2 over 12. You can go ahead and use your calculator. I'll just rewrite it here. So 169.05 over 4830 times 2 over 12. Don't bother dealing with those fractions anymore, right? They're really only important if we're, well, one, if I ask for them explicitly, or if we're adding or subtracting, right? But since we're multiplying, we can just use our calculator. And so we've got, we can simplify, how do I turn this on? 4830 times 2 over 12. I get, let me just double check here. Okay, 4830 times 2 over 12. I get R is 169.05 over 805. So R is 169.05 divided by that previous answer. Thank you, 0.21, right? This is per year, right? Or 21% per year. For the monthly rate, we just take R and divide it by 12, right? We take the 21% and we split it into 12, and that's our monthly rate. So R over 12, which is 0.21 over 12, 0.21 over 12 is 0.0175. So the monthly rate of simple interest is 1.75%, right? If you multiply this by 100. There is a percentage button on your calculator, but it takes a percentage and converts it to a decimal, right? So if you have 21 on the screen and you hit the percentage button, it'll convert it to 0.21, but not the other way around, I don't think. No, it just keeps going. It's essentially a divide by 100 button. Kind of silly. Okay. So for rates, you should always give it as a percentage, right? And so you always want to work in the decimals, but then bump it up to a percentage because that's what we talk in, right? Or we could also solve for R. Did we solve for a PT? I guess not. Or we could solve for R, right? I equals PRT. So R is I over PT. Same idea. You get the same results. You would still have to do the work with the T, and you would still have to do the work on the R to convert it, the T to years and the R back to months, or the monthly rate. Right? That's just the middle calculation bit. Any questions about that? No? All right. Are you guys ready to get into the fancy bits of your calculator? Yeah? Nice. It's like, we'll wait till tomorrow then. No, we're gonna use our calculator. So 4.3 is days between dates. Days between dates, which we abbreviate DBD, days between dates, on your calculator. So if I asked you to find the number of days between September 4th, 1978 and December 3rd, 1981, that feels like a lot of work. Almost impossible. Yeah. Hopefully it feels impossible, because I don't know what, I guess you could go back, figure out if it was a leap year, you'd have to take things like that into account, right? But our calculator can do stuff like that, okay? And so for time, right, we can figure out the days between two very specific dates, right? And that can be our time value, right? It's gonna be in days, so we're gonna assume that each year has 365 days regardless of the year, if it's a leap year or whatnot, right? And so, well, that's the only option, but still. So we're gonna assume 365 days per year, right, for all the years. But our calculator is gonna be able to calculate days between dates. Okay. To access the days between dates function on your calculator, you're gonna go, I'll see if I can show it, but it's over the one button, or sorry, yeah, one button. There's date, right? And so if you go second and then one button, but second function date, okay, it'll give you a bunch of gibberish, okay? But first, let's start there. So you hit your second button, and then you hit the number one button, which is the date function, or I guess it's capitalized. Date function. Let's see if I can. How did I show it before? Yeah, right? But I had something weird going on with this, I think. Something weird, right? All right. If you don't have your calculator out, now's the time to do it. Okay. Okay, that's pretty good. Hey, it's even right side up and everything. zoom in. That's all I can do. I guess there's an app that you can buy to get it on like to get this calculator on your phone or your iPad. Wouldn't that be handy? But it's like $14. I'm not spending that. You crazy? So anyways, here's the date function. And I guess when you hit it, it doesn't show the buttons that you click. So it's like secret clicking. Anyways, we'll make do with this, okay? And so here's the date button, right, the number 1. And so you're gonna hit second and then 1, and it's gonna take you to this screen here, right? And so it takes 3 inputs, right? Or really it takes 2 inputs and it spits out the third, okay? It needs the first date, date 1. And then if you scroll down, right, so here you've got these up and down arrows. If you scroll down, you've got date 2. Okay? And if you scroll down again, you've got days between dates. Okay? So as long as you feed it 2 of those 3, we can go back and make it compute the third one. Right? And so when you're showing your work for calculating days between dates, you're going to give me the inputs that you gave it and then the output that it gives you. Okay? And so, I don't know what ACT is. ACT. It's nothing. Just ignore it. Okay? So we're only going to deal with date 1, date 2, and the days between dates. Okay? So I'll come back to this, but let me just, right here. The date function takes 2 inputs and gives 1 output. One, date 2, and days between dates. What that's saying is that we give it any 2 of these, any 2 of these, and it can solve for the third. Okay. I'll just make a note here that you use the up button and the down button to scroll through the options. One thing that's really important is because it takes a very specific format, okay? So the dates must be entered in the format, in the format month, period, day, year. Very short-sighted of them to only do, so why do I say that year? At some point, right, we might be interested in 1975, but also 2075. So you'll have to buy a new calculator then. But until then, they haven't quite got it figured out. They should have made it year, but that's okay. Right? Or maybe even that's short-sighted, right? year, 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 year. No. That's crazy. Okay, so you'll want to make a note, right? Because that's not on your formula sheet or anything, but you will need to keep it handy, right? And so you'll have to enter month, month, dot, day, day, year, year. Okay. After entering a date, and I'll show you what I mean, but after you enter a date, you have to hit enter on the calculator, otherwise it won't save it. Okay. So after entering a date, we must save it by hitting enter. After you've filled in the two inputs, right, and you're ready to get some output, right, so you're ready to get the third result from the calculator, what you're going to do is you're going to scroll to that one that you want to solve for and hit compute, which is the CPT button, and I'll show you in a bit. It's just hard to juggle the two. Okay, so after filling in the two inputs, scroll to the output, whether that's date 1, date 2, or the days between dates that you want to calculate, and hit CPT compute. So let's do what we do here. Okay, mine's gone to sleep. That's all right. Okay, so it comes up in this format. I think I reset mine to default option, so yours should look similar, right? When you go to the dates option, okay, I'll clear out of here because we go second date. Okay. And so, I don't know, what do we want to calculate? Days between dates. I don't know. How many days old am I? That might be fun. Date 1 has to be my birthday, April 30th, 1986. Yeah, you heard that right. Write it down. Okay, so April 30th, we had to have, remember, month. It's a secret marker. How about this one? Month, period, day, year, right? And so for me, right, date 1 is April 30th, 1986. In month, day, year format, how do we write that? Month is 04.3086, right? Date 2, well, today, right? And so today is what, October 15th, 2019. Feeling old suddenly? That's all right. October is what, the 10th month? 0.1519. Okay. That's all right. Everyone's gonna feel old once you do your how many days old you are. let's see here. So date 1, 04.3086. Notice how it's not saved, right? And so you'll know it's saved when it says date 1 equals and it's in that proper format, right? So until we hit enter, it's not going to be saved. So you want to hit enter, and then it shows up in the right format, right? So now we know that it's saved as date 1, and I can scroll down to date 2, which we're going to put in as today, right? Today is October, so 10.15. Oh, it's trying to take a picture. It's not going to be a very good picture. 2019, 19. Again, we have to hit enter, otherwise it won't save, right? So we have to hit enter here. And now I can scroll up. April 30th, 1986, that's still good. Can't really see with the glare. October 15th, 2019, right? So now the one I want to solve for is the days between dates. Right? Here, it's just going to have the most recent answer that I gave you. And so it's not until you hit compute that it's going to do anything, right? So don't be thrown off if there's a number there, right? That'll just be from your most recent calculation. So you want to make sure that you hit compute, right? The CPT button. Compute. That's a lot of days. 12,221 days. Living everyone like it's the last. No, probably not really. But anyways, so there you have it. Okay. All right. So like we said, if I wanted to, what if I wanted to know what date was I 10,000 days old on, right? Then what I'm going to do is I'm going to change the days between dates. I'm going to force it to be 10,000, for example, right? And then again, I have to hit enter before it's going to lock that in, right? I can scroll up. It's kept date 1 and date 2 because I haven't computed anything. Right, but if I'm talking about how old was, or when did I turn 10,000 days, right? I want to keep date 1. Date 1 is still my birthday, right? But I'm going to compute date 2, right? And so what I'm going to do is I'm going to go to date 2 and I'm going to hit compute. It was a beautiful Sunday, September 15th, 2013. That's when I turned 10,000 days old. September 15th. Maybe it was a beautiful Sunday, I don't know. Anyways, okay? And so you can, like I said, as long as you give it 2 of the inputs, you can compute the third, and I call it an output. Okay? Any questions about that? Let's do some examples here. Maybe I can, it's kind of fun to be up here. It's been a while since I could stand. It's harder to write, so we'll see. Okay, let's do an example. Example 139. Do you guys like it when I pull in the screenshot or just write it out? Screenshot. High tech. Can do. Where did I put it though? Here. Example 139 looks like this. Looks a little something like this. Boom. So, example 139, calculate the amount of interest owed on a loan of $3,800, which was advanced on June 17th, 2005, and repaid on October 1st, 2005, at a rate of interest of 10.75%, right? We assume it's per year because it didn't specify, right? So we're given that, well, P is 3,800. P is always your initial investment amount or the initial loan amount. And we're given date 1 and date 2. I'll just write them here. Date 1 is June 17th, 2005. And date 2 is October 1st, 2005. And R, the rate of interest is 10.75%. So we rewrite that as 1.075 as a decimal. Okay. Remember our formula, right? And so we want to find I, right? Because it says calculate the amount of interest, right? And so that's how we know we have to find I. I is PRT, right? And so to find T, right, we have to use our days between dates function to figure out how many days there are and then divide by 365 to get it into years. So we need to use days between dates to find T. Right? Here's how I want you to show your work when you're working on your calculator, right? I want to see the inputs that you're giving it, right? And with a star, you're going to indicate which one you got it to calculate. Okay? So date 1 is, because we're kind of fresh to this month, dot, day, year, right? I'm just going to make a little note here. Month, dot, day, year for each of these is, so June is 06, 1705, and October is 10/01/05. Right. So what we have is date 1, date 2, and days between dates. Date 1 is 0.06.1705, 10.0105, and then I'm going to indicate which one I'm calculating with a star. Always indicate the one you are calculating with an asterisk. Or with a little star. Right. Usually, obviously, in the same color, but that's how I'll indicate that, hey, this is actually output from the calculator. Because what we're going to be doing later on is a lot of our work is going to be on the calculator, right? And so to show your work on a test, for example, right, you're just going to tell me what you gave it as an input and then what it gave you as an output, right? And so we have to get get on the same wavelength for how I want you to present your work. Okay? But if we go ahead and plug these in, second date function, date 1 is 06.1705, enter, right? Don't forget to hit enter. Date 2, 10.0105, enter. Days between dates, compute. I get 106. Okay. So make sure that that's what you get. Of course, this is days, right? So you want to make a little note to yourself that this is 106 days, not 106 years, right? We need to convert 106 days into years. I'll put this note in red. Note. We will assume all years have 365 days. Right? So we will assume all days, or all years, sorry, all years have 365 days. So a year has 365 days, 12 months, 26 biweeklies, right? But we'll get a better handle on that kind of stuff. 52 weeks, all that fun stuff. So T in years is 106 days divided by 365. And you can just keep it as 106 over 365, right? There's no need to convert it to a decimal, and then because then you'd have to carry all those decimals, right? And so it's easier to just keep it as a fraction because we're just multiplying, because now we need to know I equals PRT. Remember, what we're solving for is the amount of interest, right? And so we had P was 3,800, R was 0.1075, 3,800, 0.1075 times T, which is 106 over 365. Right. Multiplying fractions is all safe. And so we get 3,800 times 0.1075 times 106 divided by 365. My full answer, so that you can check your work, is 118.6328767. There's no reason for you to get a different answer, right? So you just want to make sure that you get the same one I do. In dollars, it's $118.63 pennies. Any questions about that one? Okay. Let's do another example, example 140. On June 26th, notice that we don't have a year, right? In that case, right, if we read the question on June 26th, Laura put $2,750 into a term deposit until September 3rd. Reasonable to assume that if it was any different year, right, a year later, September 3rd or something like that. But because it looks like they're in the same year, we can just pick any year. right? And so it won't matter which year we pick between June 26th and September 3rd. And so she's going to withdraw the money September 3rd when she needs the money for tuition, books, and other expenses to return to college. What a lucky girl. For term deposits in the 68 to 89 day range, so our days between dates are probably going to be between 60 and 89 days. Let's check, but her credit union pays an interest rate of 4.25%. How much interest will she earn on the term deposit, right? So we have to find I again. Mostly just practicing days between dates. So what are we given? We're given that P is 2750. Date 1 was June 26th. Okay. And we can pick any year. Let's use 2019. I don't know, let's go crazy. Say it's this year, nice and fresh. As long as we use the same year for both of these dates, it won't matter. Date 2 is September 3rd of the same year. And blah, 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 blah. The rate of interest is 0.0425, right? 4.25%. It doesn't specify, but that's why we can assume that it's per year. All right. There we go. And we want to find I, the amount of interest. So need to first find T using the days between dates. So I've got date 1, date 2, and the days between dates. Here's where I'm going to indicate that, okay, date 1, date 2, I'm going to be calculating the days between dates. Date 1, remember, has to be in the format month, month, dot, day, day, year, year. So date 1 is June 26th, 06.2619 for this year. If we wanted to, you can pick any year. Date 2 is September 3rd, 090319. Notice I'm not saying this period or decimal, right? But it has to be there. I forget sometimes to say it, not to do it though. Okay. So if you go into the date function again, date 1 now is 06.2619, enter, right? Otherwise it won't save. Scroll down to date 2, 09.0319, enter. And then scroll down to days between dates. Notice that it's probably at 106 still from before. It's not until you hit compute that it's going to give you the fresh answer. So hit, pardon? Oh. Compute 69. So, all right. So even though it's all in the table, right, the way that I can indicate that, hey, this is a value from the calculator is with a star, right? So we've got 69 days, which does in fact match up with the, for term deposits in the 60 to 89 day range, right? So it does satisfy the 60 to 89 day range. So our interest rate applies, right? And so T, therefore T is 69 over 365. So now we can calculate I equals PRT. P, we said, was 2750 or 2,750, I guess, sorry. The rate was 0.0425. And T, as long as you use 69 over 365, you'll be safe. So 2750 times 0.0425 times 69 divided by 365. Check your answer here. I'll do the full value, 22.09417,808. In money, though, that's $22.09. Any questions? All right. So days between dates. You could, like we showed, we didn't do an example of it, right? But I could say something like, oh, he had to pay his loan back 300 days later, right? On what date did he have to pay the loan back, right? That kind of thing. Then you have to calculate date 2. But anyways, you'll know it when you see it. But pretty fun function of the calculator. All right. So, no questions? No? Just keep going. Got it. 4.4, present and future values. Okay. What you'll find for each of these sections or chapters that we're going to work through, except for the last one, is we introduce a new concept, and then each of the section looks at solving for one of those components, right? So here we're going to look at the present and the future value, right? The future value formula. And then we solve for R and we solve for T, and kind of very similar to what we've been doing already. But a little diagram of what's happening is usually we deposit some money. Today. And then after some time, I withdraw more money than I deposited, right? Because I've earned interest on it. So withdraw money, withdraw, I'll put in brackets more money later, right? At this later date or future. So the arrow represents time. And in terms of what we have going on here in terms of terminology, here we have our present value. Oops. And then later we have our future value. So in terms of notation, right, we've got P, and then after some time, at a rate equal to R, time is unknown, right? But this is just in general. We arrive at P plus I, which is the future value. Oops, I'm going to write those in different order. I'm going to write future value equals P plus I. Which we already hinted at, right? And I said, don't worry, we're going to talk about that more later. And here we are. After some time, ironically, talking about the future value. Okay. If we think about FV is P plus I, right? But if we also know, did you get your test? No? Grab it there. Make sure you grab your test before you go. We know I is PRT, right? So we can replace I with PRT. Because that's the formula that we had, right? So the future value is the principal amount plus the amount of interest that I'm getting. And in total, that's my future value. So now I can collect like terms, right? I can factor out a P, right? I can factor out a common P and rewrite this as P times 1 plus R times T. Right? And that lands us at the future value is P times 1 plus R times T, which is on your formula sheet. Notice on your formula sheet, there aren't that many formulas. We've already done 2 out of 3, or we've already seen 2 out of 3 of them. And you can probably guess what the last formula on here is, right? That's if we have a changing interest rate, right? It accounts for different rates at different intervals of time, but we'll get there. Just in terms of wording for problems, I just want to mention that the maturity date is the last date of the term, so it's the date of the future value. Okay. And so just a little note here, mostly for if you're doing problems in the textbook, the maturity date is the last date of the term of the investment or loan. Did you grab your test? Hey, did you grab his test? Now I'm stuck with it. Looks like that guy didn't want it either. Or maybe he grabbed his, I don't know. You grabbed it? Less for me to carry back to my office. Anyways, all right. So now, same idea that we did before, right? We had a formula, I equals PRT. That's going to be a pretty minor player, right? But it does get us warmed up for solving for values, right? Because they're all multiplying, they're nice to deal with. Here, we'll have to do a little bit of work to solve for things like R and T, for example, right? But we'll look at each of them, right? And so for each of these examples, we're going to go through and we're going to solve for a future value, and then we'll have a different problem where we solve for the present value, a different problem where we solve for R, and then a different problem where we solve for T, so that you've seen how to solve for all of these, right? Little tricks along the way. So we'll jump right into example 141. And I'll just move it down a little bit and make a note here that we're solving, oops, can't write at all. Solving for the future value, and I'll just kind of give it a little highlight here. And I'll try to remember to do that for each of the new ones that we're doing, but I might forget, so you have to keep me honest. So calculate the maturity value, there it is. The maturity value is the value at the maturity date, so the future value of a $15,000 investment at a simple interest rate of 4.75% after 1.5 years. And so now we want to find the future value, right? You could go ahead and say, well, I know the future value is P plus I, and because you know P, you can calculate I, right? You could go ahead and solve it that way, but I would prefer that you just stick to this new formula for the future value, because that's going to be the one more similar to what we're going to be dealing with later. And so I prefer that you just work with this one now. So let's outline what we've been given. Calculate the maturity value of a $15,000 investment. So the initial investment, the principal, or the principal is $15,000. The simple interest rate of 4.75%, we have to convert it to a decimal, right? But 0.0475. But because it doesn't mention per month or per day or anything weird like that, we can assume it's per year. And T is after 1.5 years, so we can just use 1.5. Right? So there's no curveballs here, right? But you do have to keep track of, okay, R has to be per year and T has to be in years. Right? All right, so now we want to find the future value. We'll start with the future value is P times 1 plus R times 2. These little itty bitties, it's just a matter of plugging in the numbers, churning it out. So we get P is 15,000 times 1 plus R, which is 0.0475 times T, which is 1.5. One thing that I could see maybe happening if you're not paying attention to your BEDMAS, right, the rules of math, is if you added this one to this one first and then multiplied, you'd get the wrong answer, right? So you have to think BEDMAS, right? You've got brackets, and then inside you've got more brackets, right? But inside those brackets, you can't do anything. So then we move out exponents. There are no exponents. Division, multiplication, we have multiplication. So we have to deal with this first before we can add it to 1. Right? So you want to really have a good handle on the rules of math. Right? And so we have to solve this before we can add it to 1. What's nice is if you just get in the habit of always doing that, right? That's how they'll always behave, all these problems, right? And so then it's not that bad. So we get 15,000 times 1 plus 0.0475 times 1.5 is 0.07125. Remembering if you had more decimal places, you could use the store function, right? Store in whatever value you want and then recall whatever value you picked. Okay? Because you have to keep all your decimal places. We're talking money, so that's important, right? So now we can do plus 1, so we get 15,000 times 1 plus 0.07, so 125, so 1.07125 plus 1, and then times 15,000, 16,068.75 even. So that's nice. I didn't have to do any rounding. It's almost like they planned it. Okay. So this is the amount. If you invested $15,000 at a rate of 4.75% for 1.5 years, you would be walking home with $16,068.75 total, right? That's your $15,000 that you invested plus your interest, right? So that's your future value. Okay. Any questions about that one? No? Let's do one where we solve for P. Solve for P. Again, I'll kind of highlight this. We're going to do example 144. Might have to bump it down here. Let that page break to deal with. Clean slate. There we go. So same idea, right? Here's a problem where we're going to be asked to solve for P just to show you how it works, right? But same formula, just different approach. So what amount should be invested today, right? So it's asking what is the principal amount in order to receive a maturity value of $17,000 in 8 months if money earns 9% simple interest. Okay. So let's see what we're given here. We're given that the future value has to be 17,000, right? The maturity value is the future value in 8 months. So T is 8 over 12, right? 8/12 of a year. And R must be 9 divided by 100, 0.09, right? Because it didn't say per month or anything like that, we can assume that it's per year. And we want to find P. So what amount should be invested today? That's P. So we start with the same formula. Future value is P times 1 plus R times T. Now we know the future value. I want to find P. I know R and I know T, right? So I can plug those in and I can solve for P. So I know the future value is 17,000. P is what I'm trying to solve for, times 1 plus R, which is 0.09, times T, which is 8 over 12. Okay. Again, making sure that you solve for this value first before you add it to 1, right? And so I'm going to solve this portion first. So 0.09 times 8 divided by 12. And then adding 1, oh, I guess I shouldn't skip steps here. 17,000 is P times 1 plus 0.06. So 17,000 is P times 1.06. Solving for P, right, we have 17,000 divided by 1.06. P is 16,037 0.73585. You want to make sure that you get the same, exact same values. In money, 16,037, oops, 37.74. Because we have to round it. Or we could have solved for P and then plugged in our values. Right, so if we have the future value is P times 1 plus R times T, solving for P, right, we have the future value all divided by 1 plus R times T, which is what we ended up doing, right, just with the numbers inside. And so either way, you will arrive at the same result. The solution will be the same. So it's just a matter of if you like to clean up your equation to what you're solving for, right? Or if you like to plug them in and then move things around with numbers, which is what I prefer, but maybe it's not what you prefer, the solution will be the same. Okay. So, I know you can tell do I start this next one or do we save it for next day? Next day, sold. It'll be a good review for the days between dates and stuff. But yeah, nice work, guys. Make sure you pick up your test before you go. I don't want them. And I'll see you guys on Thursday.